All right. Today we are talking about measures of position. So remember, we had measures of central tendency, which is where they fall in the middle, what's central to the data. Then we had measures of variation. So that's like how far did each data point fall from the middle. And now we have measures of position, which is just saying where any entry falls within the set. So something you should be familiar with is a box and whisker plot. We know that these are some middle school standards, but it's probably been a while since we've done it. So I wanted to break that down for you. So box and whisker plots work off of quartiles. So if I just scroll here a little bit, we see that we have kind of four quartiles, but we really list the three. You have your Q1 is your the 25% of the data. Q2 is 50% of the data, so that's always going to be your median here. Your Q3 is 75, this would be 100%, and this would be 0. So you start with your minimum entry, and you end with your maximum entry, and you're just going to draw a number line all the way through. So something with this number line is you do want everything here to match and be incremented properly, just as we would on a graph and a histogram. So if this is 1, 2, 3, 4, 5, 6, 7, as you'd count, you'd want everything to be evenly laid out. And then you place your Q1, Q2, and Q3 where they belong. They won't necessarily all fall in the middle like this. So you can see we have like some skewed ones. Sometimes your box is really small and on a long whisker. And so you do want to make sure that you have some sort of number line increment there. But anyway, we start with our minimum entry and then our maximum. And then I always go for my median. And in order to find your Q1, which is going to be your 25% of your data, you would count, just from your minimum to your median to see what your middle point of your data is and what's your 75%. So that'd be the median of your median and your maximum. We call this a box because this is the middle 50% of your data. Think about that, from 25% to 75%, 50% of your data is going to fall within this box. This is the 25% under, and this is the 25% that's over. And then the outside is our whiskers. The whiskers do not mean that they are outliers. The whisker just means that those are outside of the middle 50%. So if you want to be on average, you kind of want to be in this middle box. If you want to be above average or below average, you'd be on a whisker. We have this word called interquartile range. We use IQR for short because who wants to spell out interquartile every day? So we use interquartile range, which is just the range between your Q3 and your Q1. So that's going to be the range of your box, pretty much. So we are finally getting an official way to find an outlier and not just drawing a graph and saying, well, that looks far away, or that seems a little low, because it may not be an outlier. Officially, you take your IQR, say that this is literally a spread from 0 to 100, and this happens to be 25, and this happens to be 75. It doesn't always work out that way. That we have an IQR of 50. We would do 50 times 1.5. And then 50 times the 1.5 would be 75. So if someone scored, now your IQR, so that was your 50 times the 1.5, so it's 75, so 75 higher. So if somebody scored 125 or negative 125 on this test or whatever it may be, that would be a true outlier. So whatever your IQR is, multiply it by 1.5, and then you're going to subtract that from your Q1, or you're going to add it to your Q3, not to your maximum and minimum entry, obviously, because your maximum or minimum entry, if something's going to be an outlier, is most likely that outlier. And then the last thing we need to talk about here is skew. So remember, here would be like our Q3 and our Q2. And then we have our Q2 and our Q1. So when there's no skew, when it's normal, these two pieces are as equal as possible. When it is right skewed or right tailed, you want to think that it's longer to the right. So you have more people scoring above your median inside of your box than you do below your box. And then the same thing for the left skewed, meaning within your box, you have more people in the first half of your box, the left side of your box, than the right. Your tails can play into this as well. And you can see in both the pictures that I drew how the tails kind of were longer on the right and the tail was longer on the left, for the left skewed, and that is consistent with our normal distributions. So we're going to spend a lot of time today, the first lesson, going over box and whisker plots and quartiles and interquartile range. But the other way that we measure position is via a z-score. So z-scores are so imperative to statistics and the study. We study it all the time in normal distributions, and we can do z-tests, and it's just something we'll be using the rest of the year. And it has to do with this formula right here. So we have our value. Our value is usually x. We're going to subtract the mean, and this could be your population mean, how we have mu here, or it could be your sample mean, which would be x bar, and then you're going to put that over your standard deviation. So you're taking your value. So you're saying, what's my value, and how far away from the mean is it? That was our little variances before, and then we're dividing by the standard deviation, because we're going to say, well, how far away is normal? That's kind of what we're saying here, is what's the distance from my point to the mean, and then how does that compare? What is that in ratio to the standard deviation, which is what we said was like the accepted distance away. Z-scores can be positive and they can be negative. A positive z-score is just going to mean that your value is bigger than the mean, and a negative z-score is going to mean that it is less than the mean, so it would fall to the left. And if you have a z-score of 0, it just means that you have the exact mean. The only way to get a z-score of 0 would be for your numerator to be 0. So if I had a mean of 10 and my value point was 10, obviously it is the mean, so it's super average. And then another way to find an outlier would be a z-score of positive or negative 3, further than our mean. So this could be an outlier. It's not necessarily always, but usually. So some of your homework problems, we're going to say, is the z-score usual, unusual, or very unusual? And so we kind of have this little chart here that we use. We have our usual scores that are within 2 standard deviations of our mean. This is going to be a z-score of 2. It's pretty usual. Anything between 3 and negative 3 is a little unusual, but any z-score smaller than 3 or negative 3 or bigger than positive 3 is going to be very unusual. And then just on the side here I have, you can divide data into deciles or percentiles as well, just in case you don't like using the z-scores. Percentiles are also a thing, again, that we will go over that together. Just so you know, percentile is out of 100 and a decile is out of 10, so ranking from 1 to 10 instead of 1 to 100, just so we have that bit of information there. So a lot of really cool information here when we talk about measures of position. And again, we'll break that into 2 different days, one that we kind of focus on quartiles, skew, box and whisker plots, and another where we talk about z-scores.